Well, ladies and gentlemen, a very, very warm welcome to this event, which is put on by the Royal Society of Edinburgh and the National Museums of Scotland. My name's Graham Kye. I'm the Vice President of the Royal Society of Edinburgh, and it's my great privilege and pleasure to welcome you all, and particularly our speaker, Professor Jeremy Watson and Mrs. Watson. We're delighted that you're able to come. First of all, I was asked to give a few housekeeping rules, but you can see that. You know where to go. That door there, door at the back, and across to, if there's an alarm, to outside the George Hotel, which has got a very good pub, by the way. So see what happens. Can I ask you to switch off your mobile phones, please? And this is simply to tell you that the lecture will be audio recorded, and an edited version will appear in the RSE website. And Butterfly Films at the back there are filming this, and the videos will be available shortly on RSE and the National Museum of Scotland's websites, and on social media as well. I've been asked to say just a few words about the Royal Society of Edinburgh, because some of you may not be acquainted with what we do. We're founded in 1783. Founding fellows amongst them is Adam Smith, Benjamin Franklin, and later names such as Walter Scott, James Clerk Maxwell, and more recently Peter Higgs are fellows. It's Scotland's national academy, and we serve all of Scotland. We go to give lectures, and I was in Wick just a few weeks ago, I was in Fort William, etc. We're all over Scotland, and we cover all areas: arts, humanities, sciences, medicine, creative arts. J.K. Rowling is one of our fellows, social sciences, public service theology, and law. And we're completely independent, non-party political, and we undertake quite a few major public inquiries on issues of national and global significance, such as climate change, digital future of Scotland. And we give briefing papers for MPs, MSPs, and MEPs. So we do a lot of work in schools. We're on lecture series, debates in schools, and of course public lectures, as tonight, and not only in Edinburgh, but I said all over Scotland. And recently, because most of us, of the fellows, are rather old, like me, we started a young academy, and this is for early career researchers, maximum 40, very old age to be a young academy. But we also give out a lot of grants, research projects, international exchanges we fund, and we give awards to a wide range of people in creative arts, sciences and medicines, and a lot of prizes in many of these areas too. Anyway, that's roughly what we do. And I should also explain that this lecture is part of the Edinburgh Lecture Series, which is led by the City of Edinburgh Council in association with Creative Scotland, and a number of universities, the universities in Edinburgh, the University of Edinburgh, Napier, Heriot-Watt, Queen Margaret University, the Open University as well, and I've mentioned already National Museums of Scotland and One City Trust. So the Edinburgh Lecture Series, Edinburgh Lectures 2014, this programme features speakers chosen to reflect a year in which Scotland is showcasing itself with the Commonwealth Games, the Ryder Cup, etc. And the programme theme is city, community, and home. And of course, who better can we have to address us on this theme but Jeremy Watson. Jeremy is Professor of Engineering Systems in the Faculty of Engineering and Vice Dean of Engineering Sciences at the University College London, where he works in the Department of Science, Technology, Engineering and Public Policy. He worked as Arup's Global Research Director between 2006 and 2013, and until November 2012, Jeremy was Chief Scientific Advisor for the Department of Communities and Local Government. He was awarded the CBE in the Queen's 2013 birthday honours for services to engineering. Jeremy is a former board member of the UK Government Technology Strategy Board and a board member of the Institute of Sustainability, having previously been one of its founder trustees. And he serves on the Council of the Engineering and Physical Sciences Research Council, the EPSRC. He's an engineer by training, and his experience as a practitioner and a director of pure and applied research and development in industry, the public sector, and academia. He has held research and technical management roles in industry and universities, plus voluntary service with the DTI and BIS. His interests include interactions in and the design of socio-technical systems, emerging technology, identification, development and deployment, and strategic innovation processes. So we're delighted to have that he's accepted our invitation, and he's going to address us today on the topic of challenges and opportunities in future cities.
Well, thank you very much indeed, Graham. That's such a fulsome introduction. I hope I can live up to that. It's a privilege to be here. I'm very glad to have been invited, and thank you very much for that. As I came in through the airport just a couple of hours ago, I noted one of the quotations on the billboards there. Edinburgh is a city which encourages you to think about what a city is. Apparently this was Murdo MacDonald. I didn't have time to Google Murdo, but I'm sure you'll know him. And I just thought that's probably quite an interesting thing to ponder this evening, you know, what actually makes a city and how do the future opportunities and challenges colour our thinking about that. So I wanted to talk just brief before I start, you know, what have I got to say about these things and from what position. So I recently moved from Arup to Willis, which some of you may know is a major insurance company. And so now I'm looking, and I'll talk a little bit later about that, how science actually leverages the way we can de-risk capital, for example. Graham has done a very good job in covering the other points there. But I have to say that one of the major, I suppose, enlightenments I had was when I worked in the Department of Communities and Local Government, where I really learned about social sciences and the importance of social sciences and the integration of that discipline with physical science, and how important it is to think about human-centred design, which I think is the core, really, of what we think about in smart cities. Also, I'm Deputy President of the IET. It used to be the IEE, and that gives another interesting angle. The IET now is looking right the way across the engineering disciplines, and indeed including the built environment. So I've made this talk really co-sponsored by the people who've supported me in this. So Arup, for whom I still do some consulting, is a major company, engineering consultancy that employs a lot of people. It runs under a trust, so it doesn't have shareholders. It's employee-owned. And one of the iconic pieces of work that it did was the Beijing Olympic Stadia. This one, of course, being the water cube, the previous before last Olympics. Willis is all about insurance, but it's actually supporting a lot of work in climate change and modelling and so on, catastrophe modelling. And UCL, of course, is well known, certainly to the sort of academic colleagues around the room, which I think pioneered connecting the sort of siloed disciplines of engineering and science through global challenges. So the previous provost, Malcolm Grant, proposed that there should be a number of challenges, one of which is future cities, and that marshals the thinking between the departments to come up with some novel interdisciplinary thinking. That's the end of I don't think this is really a plug, it's just an explanation from what point I'm viewing the whole picture. So the thing that immediately grasps one, I think, or seizes one, is the fact that cities are systems of systems. They're highly complex. And when the Technology Strategy Board was looking at the city's catapult, it had quite a bit of persuading to do for its governing board, I think, to persuade them that actually you could get hold of something when you think about cities that provides a holistic challenge. And in fact, I think a number of academic and companies, you know, company interests are still finding those ends of the ball of string, if you like, for cities. But most definitely there are some real challenges there. And of course, this is obviously a view of London by satellite at night. And you can see the M25 very clearly. Those who know London well, I'm sure you all do. And behind that sort of nebula of light, the deep complexity of what's going on there and all the interacting systems in infrastructure, communications, water, and so on, power, you can just envisage. And you can start to maybe diagram those as in a block diagram form and start to look across the sort of social and technical domains where you can see there, hopefully it's legible, the key issues that people think about, community and people being at the centre, water, wastewater, food, logistics, and then some of the energy sources and all the interactions that work between them. And those interactions represent business models, they represent research topics, They represent areas that can be optimized through better governance and through better understanding, because typically city systems tend to be self-organizing and not necessarily optimal. And I think big data and the future opportunities through ICT and sensing and so on, analytics, is going to unpack some of those opportunities for us. I shall talk about some of that later. Then there are the contexts at different scales. So we are all dealing with products and with the finance means to buy them, smart cards and the means of transport, cars. We look at buildings, domestic, commercial, public buildings, infrastructure, transport and the utilities, water, waste, communications. And we're thinking right the way up to districts. And a bit later on I'll talk about some work that I've sponsored which tries to map the way in which design and engineering influence behaviour and outcomes. And if we can understand that better, we can optimise what we design so that those things become better for people, we get better outcomes, better economic benefits, and so on. So the key themes that challenged me when I sat down and wrote this talk, I wrote a mind map, in fact, of what I was going to say. And these things came to mind, coloured by my experience in the various domains in which I've worked. So sustainability, now rather an overloaded word, I think, in fact, but still very important to understand. Social sustainability, environmental sustainability, and so on, points towards resource use, the way we use water, the way we use energy, how we live together, and in terms of when we design, can we make the things we design good for the future? So if we're thinking about linear infrastructure, roads and rails, will they always be used in that way, or do we think about how we can modify them to be more adaptable in the future? Climate change I'm going to talk about, again, frequently spoken of, but just a different angle. That provides us with some challenges. Obviously, adaptation is now recognised as being probably our first priority, and I'll unpack that a little bit. Resilience is very important, both to natural and man-made effects. And resilience as it impacts infrastructure, utilities, food and financial systems. And of course, with an ageing demography, we've got a very big new challenge that's emerging with respect to how we look after our older people. And then the opportunities are getting more from what we've got by getting new business models through value aggregation, innovation, economic opportunity and transparency in government, security and safety for individuals and well-being, so managing the whole life picture rather than just when people are ill, keeping them well longer and minimising their health costs. But there are enablers and threats. So the enablers are digitally enabled integration of systems thinking I've touched on before, by which I mean looking from the top down on socio-technical systems, and then innovation in business processes, which really haven't developed very far yet, where companies are looking across the boundaries into other companies and how they can work together to provide services more effectively. I'll touch upon that with respect to infrastructure. And I think the threats are associated with a lack of holistic thinking. People think in their own silos, in both the public and the private sector. And even in Singapore, where I was consulting recently, I found the same practices going on there. And we think of Singapore as a wonderful example. It is, but in fact, there are still quite a few things that need to be done. There are issues around resilience as we become more urbanised, and later on I'll say 80% of the GDP of the world is kind of coming out of urban centres. So we become more at risk, if you like, from things going wrong in parts of the interdependent systems that we use in cities. And slightly technical term, politically modulated, we need to have some sort of continuity in the way that government is working to enable us to have some predictability about the support we need to achieve the outcomes. And obviously in the UK, the recent comprehensive spending round for science and engineering has given us that continuity for a few more years, which is a great thing. So the first point I wanted to sort of look at involves the climate and the influences on buildings and infrastructure. Very well understood, I think, in some places, but probably not fully appreciated in terms of its implications. So this is a plot of the CO2 in the atmosphere, albeit only up to 2000, and this represents the so-called Keeling curve. I mean, quite interestingly, as I always point out when I give this talk, the early part of that, when James Watt was around, we started to see from records that come from monitoring and from, if you like, proxy measurements, that the environment was already beginning to be out of equilibrium with respect to carbon. So ever since we've industrialized, we've seen this climb in carbon emissions and carbon loading on the environment. And the pie chart at the top gives a view of how that breaks down between the things we do. So business, if you can read it, accounts for 32%, transport 22%, etc. Residential 23% to 27%, so the houses we live in. And in there, one of the things that I like to pick out on is that aviation is 3%, which is about the same as ICT. So we all get very concerned about the carbon impact of aviation, but actually it's reasonably small at 3%. And another insight, perhaps, is that the UK in the global picture is also about 3%. So 3% of the global problem for carbon is actually due to the UK's emissions. Surprisingly small, but we do need to set a good example, as I used to say when I was in government, so that's why we're spending so much money on it. And around 45% of carbon emissions come from existing buildings and 25% of those from homes. And clearly there are issues around tipping points. We've got Antarctic ice melting rapidly now. A New Scientist article, I think the week before last, was pointing out that within 100 or 200 years we'll see a 10 centimetre sea level rise just due to the ice melting we're seeing right now. And then, of course, we've got issues in the tundra, for example, in Siberia, where CH4 carbon methane may be released then as the peat thaws. So there are some real concerns. And, of course, methane has got a 20 times global greenhouse gas effect compared with CO2. So again, this was some data that I got from a Met Office when I was in government, and again, I found this very interesting. And also, it was good to see them doing what they were doing, which was actually to combine weather modelling, which is now very accurate, as we know, the 3-day weather forecasts are pretty good, with climate modelling. So they're now using the same model. They're using a grid of around about 12.5 kilometres rather than the larger grid before to actually model the UK. And you can see in the black line that is real data compared with the modelled data, is, bar the error bar type fits for any moment in time, really quite a close fit. And we can start to see that going out towards the end of this particular century, a very significant temperature rise. And obviously there's a lot more data that I could present, but I've not dwelled too much on this, other than the fact to point out the need for adaptation in future cities against temperature rise. So the summer of 2003, which I'll talk about a little bit later on, which showed significant mortality, in fact, and I'll give you the figures later, normal by the 2040s, and we can maybe cool by the 2080s. So we need to do something. Mitigation is very important, but adaptation is vital for people's well-being and lives. So again, reflecting on my findings and thinking when I was Chief Scientific Advisor, I put adaptation first. And when I first did this slide, I suppose it was back in probably 2011, something like that, I was almost embarrassed to put it up because people say, no, mitigation is by far and away, we must stop doing it. But actually, if we stop tomorrow, and it is important, we've still got 200 years of effect to suffer. What we've got to do is to make sure people are quite safe now. And there are the figures. So in 2003, 23,000 excess deaths and 900 actually in London and the UK generally, but London was the hot spot. So we need to design buildings to ensure that when we start complying with high code levels, and if you look at getting a bit technical, code level 6 for modern housing, windows that you can't open, you start to think about the dog in a hot car syndrome, and how scary that would be if you've lost your air conditioning, you can't open the window, and you're in a very hot city centre. So we've got to deal with that. There are other issues as well, intense rain, pluvial flooding, we've seen that. I mean, it's self-evident that weather is becoming more extreme. Then the medium-term thing for me was energy costs, so becoming a little bit more independent, perhaps, of fossil fuels, if we possibly could, decarbonising that. And I think we've got to be very careful about the messaging we give on shale gas. Shale gas is an important resource. It's not the end story. We might have 15 years of it in the UK. But if we used it properly, it would give us time to build nuclear and actually not burn coal, which is about 3 or 4 times worse in terms of carbon impact than methane. So If we got a long-term political view on that and we persuade the populace, then I think that's the right thing to go. But ultimately, and having thought through it and being anti-nuclear when I was in my 20s and 30s, I really do think now with modern technology we need to completely decarbonise electricity. Then we can do electric vehicles, for example. At the moment, if you did electric vehicles, you're still generating the power using fossil fuels. Given the efficiency of petrol engines, you might as well burn it actually in your car. It's probably more efficient. So, but with respect to buildings, I'll talk a little bit more about that. We definitely need to minimise energy consumption in buildings, whatever energy source we use. And then last but absolutely not least, we've got to stop emitting CO2 globally. Of course, I mentioned the UK is only 3% of that effect, but we'll have to live with, even if we stop now, a long time. We must bring carbon concentration to an equilibrium point. We're going to see, I think, some technologies emerge here, which will be quite exciting for engineers and scientists. So carbon capture and storage is presently quite expensive in energy. It adds a 20% cost to a power station. That's really hard in a business model. Atmospheric abatement, actually, can we design things, or can we design plants even to sequester carbon more effectively than they do now? And photosynthesis, in fact, is not optimised. Interestingly, by evolution, there might be some more we can do there, but it's very, very blue skies at the moment. So ultimately, cities and buildings viewed at district scale should be viewed as carbon neutral or even negative if we can actually get carbon to be absorbed. So these were the identified risks from the climate change risk assessment, and I led, I think it was in 2012, the buildings return for this. So I was the senior responsible officer and I looked at the consultants' reports and so on for buildings. And these are the headings. I'll read them out because I think they're really important. So non-residential and residential properties are at significant risk of flooding. And if you look back to, I'm not sure whether Scotland experienced it particularly, but certainly in the West Country, in the UK and the Thames Valley, that was demonstrated in February this year. The expected annual damage is, there is expected annual damage and some budgetary provision is needed for that and insurance, etc. Hospitals and schools are also at significant risk. The ability to obtain insurance for residential properties is becoming quite difficult, and there's actually an initiative now out to look at reinsurance for floods, and I have to be careful about the hat I wear here because of my current allegiance, but there needs to be a balance of responsibility between the property owner and the government. Urban heat island I'm going to talk about a bit later on, so there's a significant concentration of heat in cities in the centre in the summer, hence overheating of buildings. The current energy demand, of course, in the UK is in the winter, but that will tend to swing towards in the summer as more and more properties require air conditioning for safety, as is in the case in the States. And if we also then see electric vehicles being plugged in, we're going to have an energy supply challenge. There's a reduction in water available for public supply because of the urbanisation of so many people. The public water supply, demand deficits, and of course that puts vulnerable people at risk. So that leads us into the urban heating island issue, and this is a picture of London and some work that colleagues at UCL did, I think. Well, Arcadia was a consortium, but it includes some work from UCL. So they did a plot of temperature over a 24-hour cycle over many days in the summer, and you can actually see, if you like, a heat plume moving around the city. And nighttime temperatures are really the time when people are most at risk, when they feel most vulnerable, I think, to being too hot and not being able to do anything about it, when the air movement is very low and so on. And those were the areas where the risk and mortality was highest. And I've reiterated the numbers because I think, we can't overlook that too much. We mustn't overlook it, the 900 excess deaths in London and a large number more in Europe. Now, in fact, if you take that in balance, in the winter, many more people die of hypothermia, actually, at the moment, but we need to be very mindful of overheating. Overheating and other extreme weather also affects infrastructure, which we depend on, day to day with great depth. And this table came out of a publication by Engineering the Future, which is a collaboration between the engineering institutions, the PEIs and the Royal Academy of Engineering. And I would commend it to you. It's available as a PDF on the web, Infrastructure, Engineering and Climate Change Adaptation. And this, I think, is the most pithy table, which shows it's probably a bit small, but down the left-hand column you can see the infrastructure affected, and across the top the impacting factors, so high temperature through extreme wind, thunderstorms, fog, etc. And it's really quite interesting to see which elements of infrastructure are affected by those particular influences. The other factor that's interesting, which I did some work with Treasury on, is the dependence of one infrastructure factor on another. So you might find that if you have got sort of water supply running alongside a railway, for example, and you get failure in one, you might get failure in the other. So you have to think about engineering interdependencies. And you also need to think about the business opportunities of getting those under control, which I'll talk about a little bit later on. So coming back to housing briefly, I got very involved in the retrofit story. So for existing homes, this is a little bit more on the mitigation side rather than the adaptation. You'll probably be aware that by 2050, we are supposed to have cut our emissions by 80%, as in the top right-hand corner. But of course, 80% of the buildings we currently have will still be here in 2050. We're not going to demolish and build from new. And it's an interesting question as to whether one should have a sort of scrappage scheme for non-listed buildings, but that's another and rather political story. We've got 22 million homes in the UK to be retrofitted by then, which is about 1,600 a day. I don't think we're doing that at the moment. The cost per home is pretty high, £5,000 to £20,000. So the impact on the economy is up to 0.4 of a trillion pounds, which is very, very significant. And of course, the Department of Energy and Climate Change put out the Green Deal to try and impact that, but the financial model, as I can say now, I'm not in government, is doubtful, I think, and difficult in many cases. I think by 2019, all public buildings and commercial buildings, new build, have to be zero carbon as well, and that's really a very big challenge. In 2016, all domestic stock, new build, have to be zero carbon, hence the level 6 building I mentioned earlier on in the adaptation story. And the difficulty is that the fact that the housing stock is very different. You know, you've only got to look around the streets, you find that buildings that people live in are extremely different, and so standard solutions are hard to imagine. And the lack of those standard solutions means it's difficult to get costs down through the scale of the deployment, as you would say in automotive engineering, where you use the same components again and again. So there are some needs there that we need to address. The supply chain in the built environment industry is very disconnected. It tends to work by suing each other rather than working together. And Treasury took great note in this, Infrastructure UK, and the proposals there, in trying to get some sort of integrated view across the providers, the subcontractors of the industry. It's quite interesting in the built environment. If you look at the national statistics on the type of companies that do most of the work, 85% of the companies in construction are 4 people or less. And those people are then employed as subcontractors to bigger companies. So it's very difficult to get learning and best practice and skills out to that very disparate community. So deployment at scale, I've dealt with skills to install, etc. Understanding the influences on user behaviour, I mentioned in brief earlier on with respect to energy consumption. There are issues like perverse behaviours which you wouldn't expect. So if you actually tell people that by turning down their thermostats down by 1 degree, and this was actually done in a study, if you turn their thermostat down by 1 degree, they'll save £100 a year, say, and you go back a year later with a control group, you find that most people have turned their thermostats up because £100 isn't very much and they like to be warmer. So it's actually... I'm also quite concerned about smart metering because, again, you get initial interest and then that very rapidly wanes, and I'm not sure you really get the feedback you want to get the behaviours. So what we want really is de-risked finance models to enable us to secure predictable and long-term performance. And I've done some work with the banks to look to see whether investment quality audits to support pay-as-you-save schemes, which are similar to the Green Deal but done for commercial buildings, could possibly work. So in this case, you'd instrument a building and you provide a dashboard, if you like, to the funding agency to know whether or not they're getting the payback on their investment. So it's not just a fit and forget, because the Green Deal actually is based on an a priori assessment of whether there's going to be a saving. It's not done on a measurement, so there are real risks there. If you look at a particular property, and this is an old example now, so forgive me those who've seen it before. So this is a typical semi-detached house. The measures that were applied, pretty standard stuff. I suppose the only thing that is a bit non-standard is the fact they use ground source heat pumps, which are quite expensive as a means of heating the house. Nevertheless, they achieved 50% saving on bills, which was about £600 a year, and a 75% reduction in carbon pretty good outcome. But the cost, as you can see there, was pretty large, and the payback longer than most of us live in our own homes. So again, this is where the finance models are actually, it isn't really a technological problem, it's actually a problem of business models. And we need to combine a technical and a social view when we do the research on this. The other thing I found really enlightening on that was the spread. So I usually need to wander across, but you won't hear me so well if I do that. If you look at carbon reduction along the bottom there, from no reduction at all up to the goal might be 80%, versus the refurbishment cost. And these are real data points from the National Refurb Centre. So you see that getting a little bit of a win is expensive, but it's quite predictable. The spread of dots is quite small. But as you get up to the required spread, the required performance level, carbon reduction, you've actually got a very large deviation in the cost. And that implies a very immature industry to me and pretty high risk. So it's something to reflect on. I'm sure if you extrapolate a bit further there are many more points since 2011 that is tightening up now, but I just hope that we can bring the cost down for higher level refurbishment. So when I was doing that work, I was promoting this in DCLG, community local government. I was very interested in trying to mobilise activity around retrofit and getting companies and individuals and working with the Department of Energy and Climate Change to get that to happen. But what I wasn't aware of was the work that UCL were doing, which I've since become aware of, on always need to think about unintended consequences. So you make a property very airtight, you stop air movement, you reduce the air changes, you might put mechanical ventilation into the building, and this is what you have to worry about. You have to think about and address as an engineer. So now you think about things like radon, which comes naturally up through, from granite rocks, radioactive gas. I mean, don't want to cause great scares, but we do think about that. Volatile organic compounds that come out of furniture and new carpets and things like that, which are typically, complex carbon compounds. Simple things like passive smoking affects the indoor air quality. You've also got the combustion products that might come from, any leakage from heating and so on, and that leads to some of these outcomes like cardiorespiratory mortality and morbidity, which is also linked to humidity and mold growth. So again, if you're not really clearing the air, obviously people exhale a lot of water vapor, you get condensation, we'll all be aware of that, and you get black mold forming. Black mold causes spores, and that causes allergic and other dangers. So when we make an intervention, and we drive it through from government, we have to think about the other things that are going to be caused by that intervention. It doesn't mean to say you can't do it. It means it's a more complex, interdependent problem. So moving away from buildings into the sort of more social area, and I became very interested and presented to both senior officials and ministers on assisted living and the ageing demography, which is a fascinating thing, because I'm in my 60s myself, and as many of us are, I guess, sort of thinking about how things will work going forward. So the UK has, as in many parts of the Western world, a growing and an ageing population. The baby boomers are coming through, and also there are a number of people who've got at least one long-term condition that needs to be managed, 15.4 million. Numbers are going to grow. The predictions are 250% increase in 50 years. Of course, that will be a bulge. Presumably we'll get through it, and then maybe we'll make over-provision, but nevertheless, that's really important. The ageing population consumes 70% of the health and social care budget, a very significant thought. And although I haven't put it in my slide because it's somewhat apocryphal, but it came from a good source, apparently in the last 2 years of one's life, one consumes 80% of one's total life healthcare budget. So management of one's life in the last 2 years of life, where you are, whether you're in a social care home or whether you're actually in your own home, is very important. Another statistic that's interesting is that Stannah stair lifts are typically only used for 6 months after installation. But if you think about 6 months as a proportion of 2 years, as a proportion of 80% of your costs, it's pretty important actually. So staying in your own home just a little bit longer, it's good for well-being, it's good for the economy as well. But the point is that us oldies have got quite a lot of money in many cases, I mean, not across the board. So there is something that one can do potentially with that to assist. And I think there's a little bit more evidence. This is actually a European picture. And the change that's most noticeable is that long-term care shows 100% increase over 2007, 2060. So it is a real issue Pensions, healthcare, all those things are important, but not as big as that. And again, just in this table, if you just look at the growth to 2022, there's a 90% increase in public expenditure on the ageing demography. Really quite important. And some boroughs around London, as I've said at the top here, I've heard this quotation, unless we do something but different to what we're doing now, by 2030, all of the authority's revenue would have to be spent on the care of elderly and disabled people in social care homes. So that, street lights, rubbish collection, and obviously those are statutory duties, they have to be done, but there's definitely a need. So, as many, I guess, university engineering colleagues will know, assisted living is a discipline area which is helping, using ICT, to keep older people in their own homes safely and for longer. That's now quite well developed, and there are companies who are offering that. I think Philips is one, Tunstall is another. Combines sensors, IT, service packages to monitor people's movement around their own home, whether they forget to get back into bed at night if they're suffering from dementia, whether they've left taps or gas on or whatever. And although this is slightly disputed actually now, this evidence, I thought it was very impressive. The trials by the Department of Health in their whole systems demonstrator showed these figures. So this is telemedicine actually rather than telecare, but mortality reduced by 45%. And this was a large number of people, I think it was about 10,000. Emergency admissions reduced by 20%, and you can see the rest. Really very important savings. So there is evidence being gathered that demonstrates it is worth doing this. But we need research in the system scale deployment, and again in the business models through which this is deployed, and I'll talk a little bit more about that later, because it's not just about buying components from Maplin, and putting them together. Granny isn't able to do that. It's actually about a service model, really, provided by maybe health insurers. So this is kind of an overview of the way things might work. So you have sensors, local intelligence in the property itself, which might be just a PC running particular algorithms to make sure that the elderly relative has actually remembered to, as I say, to get back into bed, or if they've gone towards the front door, why were they thinking of going out? Did they have their key and all those things to remind them? Then through the internet, part of, in fact, smart cities, informal carers, services connected as well, and professional carers, medical people looking after the individuals. And there is actually a whole life story, which I think might be the next slide, I'm hoping, or the one after that anyway. The story is about medium to high level technologies which are already there. We need standardization of components and systems. Experts need to be brought in. GPs at the moment aren't necessarily convinced that this is going to work because of people's technophobia. We need real-time analysis and response from services that are capable and competent to do that. And we need to think about how building sensing functions as they come in. For example, for building information modelling, real-time sensing can actually contribute to assisted living. So I mentioned the electronics hobby store approach is not appropriate. The families just can't do that, go out and buy a bag of bits and instrument a property, but the service model is potentially very suitable if combined with other services. Can be part of a shared city system approach, can provide hardware systems which are replaced as they go out of date, and real-time monitoring of safety and well-being. And so this is the whole life story that I was touching upon earlier on. So why don't we have something that actually deals with all of us through our whole life? So initially you might have front-end loading of services for telecare in the health insurance, so we take health insurance, but actually by making measurements of our blood pressure and whatever, oximetry or whatever, on a monthly basis, we might tell our insurers how well we are, and that might mitigate our insurance costs. And then ultimately, the money we've put into that pot would pay for some of the work we need later on in real-time telecare. So it's health insurance, telemedicine, and in fact, really a sort of a telehealth approach, if you like, which in many cases, like the jawbone devices and other devices that people are wearing when they're in the gym to tell how healthy they are, is part of this story, just getting everyone to join up that whole life health and well-being story. So moving on, I wanted to talk a little bit about resilience and interdependencies, so really moving out to the whole city scale from the particular to the general. This actually is a real picture of something that held me up for, I think it was 3 hours. So just south of Croydon, which is in South London, a water main burst alongside the railway line. So I mentioned a little bit earlier on about interdependencies. You can see the mudslide that went all the way across the main lines down to Brighton. So it just shut down all of the south of England for as long as it took to dig the stuff out. There are plenty of people on site quickly. Lots of considerations in city resilience. Things we need to think about. There are things that disturb the city system: extreme weather, equipment failure, crime and terrorism, other externalities. There are vulnerabilities in food, water, energy, waste, transport and air quality. And there are interdependencies, some of which are antagonistic, like my water main near the railway, and some of which are synergistic, so you might be able to do things much more cost-effectively and beneficially if you do them together. An example recently was the High Speed 2 discussing whether they should run fibre optics down the side of the railway line. What a good idea, you don't have to cut another channel for those. But in fact, it took an act of Parliament to make the companies work together. So why is that? So there is a need to really mobilise new thinking about business models. And then the opportunities on sensing and measurement, social media location data. Our mobile devices now have GPS in them and they can measure things, static street sensing, and we can infer things from what we measure on the streets as well. And then moving on to data fusion analytics, I'll talk briefly about Glasgow's work under the TSB funding, city dashboards, crowdsourced trending. I was surprised actually how valuable crowdsourcing is. You can get high quality conclusions from sampling a large number of people. You can infer behaviours and you can mash open data with closed data to create new value, which is what the Open Data Institute is doing under Sir Nigel Shadbolt in London. I did some work for RUSI, the Royal United Services Institute, and they want me to speak again this November, looking at how things actually have knock-on effects. So this is just a very general, I'm only going to talk about this one slide, how the dependencies of one thing on another, if you take an element of one of these out, then it can affect the other part. So this is all about interdependencies, and the arrows try to show the dependency of one on the other, and you can think about that perhaps when these slides are published. But it's important to think that if you, say, took out communications, what would that do for the financial services in any city these days, where you couldn't go to an ATM, you couldn't draw money, we would be in a deep and difficult position. Similarly, the supply of energy often comes through supergrid transformers, just a few of them around a city. Their replacement time is about 3 months. So again, there are some real issues there that we need to think about and plan for. Resilience is important. We need to be able to estimate it. So this is something that academics are doing. There's a definition of resilience there concerning the maintenance of operational capabilities and subsystems with acceptable levels of degradation, so that if something happens, then okay, there'll be some degradation, but we don't want everything to shut down. We need to recognise that redundancy in systems, if we put parallel systems in, that costs money, but that if we do synergistic work, then we can actually save money, so we can manage risk that way. Excuse me while I get some water. This is an instance of an analysis that was done by a colleague working in Treasury Infrastructure UK, Richard Ploshek, came from the Royal Academy of Engineering. And I think this is quite interesting, isn't it, that this is to do with the interdependence of energy and transport, so electric rail and electricity supplies in Italy. And the plot on the left shows that the number of links you provide of redundancy only have to be double to get you nearly to 80% resilience. So you've got to really, and obviously if you want to be 100% resilient, then you'll never put enough links in, but that gives you a cost curve or a resiliency curve which has a reflected cost curve, which is quite easy to see that you can actually afford to put resilience into an interdependent system, but there's a natural limit beyond which you probably wouldn't go. And the strength of that law, I think, is interesting, which has come out of analysis. And then just reflecting on the static and dynamic interdependency story, which I've touched upon, the same picture up there, and then a picture perhaps here of an optimum value aggregated story. So let's think about sort of linear assets that connect A and B and C and D or whatever, that actually carry, their services, road transport, rail transport, and maybe you'd think about future-proofing that in some way so that, in fact, you could change the mode. Maybe we won't have road vehicles in the same way in 2080. We might have autonomous vehicles that need different sorts of pathways to follow, but let's try and design the infrastructure to give us the the very best outcomes. And then why not try and optimize the dynamics of the infrastructure as well? So, for example, street works, it's not typical for one utility company to actually notify another utility company when they're digging up the road so they can do joint works. Very, very simple things. And in fact, when I was at Arup, we tried to get them interested and they really weren't. So again, it comes back to business models. It's not really a technical issue. So moving in perhaps what you hoped I would talk about this evening, big data and future cities. So I was careful not to use smart cities because I think that's again been an overloaded word and you know, colleagues I've worked very closely with IBM over the years, but they really, through very effective marketing, have put this on the map as something that we all think about. And I went to some of the early meetings. In fact, Sam Palmisano, the CEO of IBM, and Mayor Bloomberg in New York back in the Lincoln Center about 5 years ago, floating the first ideas around smart cities and what we could do with them. They were very nebulous ideas then, but now those have come together into some real opportunities. So some of those opportunities are involved with sensing a lot more in the city, fusing different data types, whether it's street camera, sort of building temperatures and energy consumptions, into new insights. So that can give us validation of information, continuity of service, prediction of outcomes. And again, the Open Data Institute in London's done work correlating postcodes with crime figures. So you can actually get a map. If you look at big data, you can see where sort of crime is predominant in a particular postcode indexed area, but there are many more things you can do. Then there are lots of things that are going to come out in the private sector, sort of mashing data together. So that might involve, say, energy savings, combining proprietary and open data sources for knowledge and creating value. And now we can do this geographical information service type work. We know where people are and things are. We can start to manage city-scale objects, buildings, even transport infrastructure and transport hardware. Building infrastructure attributes and live information is something I've been working on recently. So building information modelling has been mandated by government. I'll talk about that just a little bit later on. And that's now moving towards live information. So if you build a road, perhaps you should put sensors in it so that you can tell when it needs to be maintained rather than having to do scheduled maintenance. Social network feeds are very interesting. For example, the prediction of virus spread by just looking at Twitter feeds. So the norovirus, the vomiting sickness, for example, has been tracked just by watching people's Twitter feeds of saying, I've just been ill. And you can actually map where that's happening versus the spread of the virus in a better way than you would, but just by looking at reporting to clinics or whatever. So there are some real value propositions around future cities. 80% of the global GDP is generated in cities. Just in China, I think it's the population of Germany is being urbanized, the equivalent of not the real population of Germany. Population equivalent to the size of Germany is being urbanized every 18 months at the moment. It's a massive move. There's a tremendous market for intelligent products and smart solutions. In particular, the size of this has been estimated in a BIS report, which Arup wrote, which is referenced at the bottom there from last year. So a huge 408 billion on smart city solutions and services. And if you take just transport as a particular example, that could well be 4.5 billion by 2018, with a much bigger market emerging as we start to look at the infrastructural bits around that. So there's definitely a reason to be involved in smart cities across the patch. You can see why IBM launched it. And this was just a few views I took from University of Salford. Have done some really good work in putting live data associated with imaging and modelling of cities. So, for example, energy mapping, actually putting the recorded figures against the building map, if you like. Social data as well, I referred to, as in the Open Data Institute work with flooding, multiple agendas, so combining a multiple view of how you design a city for optimum walkability, sort of health, CO2 emissions, illuminations, noise, and all those sorts of things, and that provides services for public consultation. So all these things are being done now, but big data in future cities is going to make that very much more accessible. So there are some service synergies I touched upon for healthcare, but there are other things that can be done. So you can look for, I mentioned briefly, the pay-as-you-save scheme, PAYS. You can start to think about delivering energy assurance for buildings across a city scale. telemedicine-assisted living I've mentioned, personalised transport optimisation. This is already being done, so you might have an app which tells you, how I get from A to B, which particular modes of transport and when those modes of transport are going to arrive and the cost to you and so on. And then, of course, some of the stuff that's already being done around security monitoring and alerts and other things, including entertainment. So as you instrument more broadly, you can bring all these things together into real-time service businesses, again, which is what people like, I guess, Cisco and IBM are interested in, the blue blocks, covering many more things than I've listed there and providing services to the built environment and to people in cities. So what's emerging from this? The next thing, okay, we've talked about big data, again, a term that I'm not terribly fond of, but broadly explains itself. In fact, when I asked IBM what they meant by big data, they meant actually data that's too big to store and process. You have to deal with it on the fly. So as it comes in, you have to deal with it as it flows into the enterprise. So it's a moving target. This is looking at the Internet of Things. In other words, where every object that has any particular functionality has actually got an identity and a presence on the web and can be interrogated, and in particular buildings. So we start to think about new services like facilities management, optimization of buildings, security, and so on. And this is work that's currently being done in a BIS specification formation exercise, which I'm helping with from UCL. So that will help us with capital and operational expenditure optimization. And in fact, the TOTEX, which is the total expenditure on infrastructure, can now be looked at by monitoring what really happens in operation. But there are some real challenges. What we need really is open systems. Everything's got to be able to plug and play. We're all familiar with that in our own computer systems, but it's not so typical in more complex ones. We need to represent things at a levels where there's commonality. So we might have a number of different existing tools of CAD data preparation tools and control system design tools. They all have to talk together. So we have to create languages that enable those to talk. And absolutely, last but not least, if you've got everything connected via the internet, you've got a huge vulnerability to spoofing, hacking, all those sorts of things. If you imagine that even roads, the measurements of whether they need maintenance could be spoofed by a hacker. So there's a lot of work going into that, and that's going to be a moving target too, because as one part of the ecosystem gets smarter, so the other part has to catch up with it and prevent misuse. Some future city examples. I'm going to be fairly brief here because I'm looking at the time. I'm not sure whether the chair is... I'm okay? Absolutely. Okay, fine. So in the BIS report, which I've cited there, there were several examples. I suppose what really emerged for me was the lack of innovation to some degree in some of the ideas, but you'll see that and make your own judgments. I selected 3 of them, and then I added Glasgow in, which wasn't in the BIS report, because I felt that I'm in Scotland, I should talk about that. And I was involved with the TSB, and so I think that's very interesting as to where that's gone. So Chicago, these were the comments that came out of the report. So the very strong political leadership, but if you reflect on the UK, the places where things really happen and where we've had elected mayors, I suppose, like London and Bristol, well-aligned governance structures, investment in the infrastructure to create the ICT capability, community engagement, getting benefits from it, and the projects they did looked at fostering technology innovation, just as we've tried to do in the UK, so creating a city as a platform really for new businesses. So by combining the data that comes out of a city, everything ranging from health data to transport data and so on, you can start to get small companies setting up and creating applications that people will buy and create economic benefit. Stockholm focused on e-government services, so they put a fair amount of money, 70 million euros, into smart city technology to support novel and untested technology projects that were actually at a public sector level. Again, a common theme is putting the infrastructure in place, so broadband networks through using fibre optic through a city-owned company. Again, it sees itself as a test bed. There's a confidence there for new business, and the Science City, a focal point for technology innovation, economic development around smart city technologies. So for me, I'm seeing sort of some generic things about business uplift, but I'm not seeing so much around the really brand new ideas coming out. I think there's a sort of, it's quite difficult to get your head around some of these city implications. Barcelona has many smart city projects in various departments in government, collating projects and dividing devising a global vision. It's a focal point again for economic development for SMEs, so that's a common theme that's coming through. Understanding the importance and the role of vertical and horizontal working, so connecting across. This is a little bit like my value aggregation story, where you're getting companies to work together to get new value. And then collaborating with other cities. And so we see the C40, which now contain, I think, 52 cities actually collaborating and sharing best practice. And again, I've been involved a little bit in that. I'm getting more so now through Willis. And I think there's some quite interesting ideas coming out, the commonalities in their experiences. And then I'm moving on to Glasgow. You may be aware the Technology Strategy Board had a Future Cities competition a couple of years ago. And they came up with a very interesting and clever idea in that they had a two-round approach where cities were invited to just put in an expression of interest, and then if those expressions of interest were invited to contribute further, they wrote a proposal for what they would do with their cities. And I think they were given, I forget how much it was, it might have been £50,000 a piece, something of that sort of order, to write those proposals, which then gave the Technology Strategy Board a tremendous range of views from the UK cities. And out of those, they then chose one winner, which was Glasgow, but also Peterborough, Bristol and London each won, I think, £3 million. And I've looked to see what Bristol have been doing. I'm not less sure. I mean, in London, it became somewhat conflated with the Catapult, which is the city's Catapult, which is located in London. But the theme was, how can technology make life in the city smarter, safer and more sustainable? And in Glasgow, they've done quite a lot very quickly, because the money had to be spent quite quickly, in combining community safety and CCTV operations into one operating room, and creating new capabilities through city dashboards, giving agencies and citizens some real-time information about those things: traffic flow, weather alerts, accident emergency times, and so on. So very close to home and quite interesting, I think, and there's still much more work to do there. I'm coming near to the end now, but something that's exercised me is I came from a pure science and technology background into one where we have behavioural influences and social sciences, and really important to get the confluence of those disciplines together. This is, I think, probably a set-up photo, but it is quite amusing. There's another one you might be amused by later. So there are some challenges. So behaviour is often a dominant effect compared with physical interventions like energy efficiency in homes. I mentioned the rebound effects with a smart meter, or contrary behaviours where being told you're saving money actually makes you spend more. So how do we engineer? The key question is that separated bullet. How to engineer design from objective outcomes. We want certain outcomes. We want people, say, to live longer healthily. How do we actually design things to help them do that? We also need to understand corporate behaviours, how people change, so transition curves from one state to another. They're S-shaped and they typically take 6 years, even with regulation driving them. The example being condensing boilers in the built environment. And then the role of regulation and fashion alongside technology. The drivers for people aren't just about being told what to do, they're also about what's attractive to do, what's human-centred. So we need a lot more research. We're not doing that research at the moment, and it's really interesting to connect up the disciplines there. We need to get the research councils on board to do that. So I set up a project which is still running, which is called DIBO, because it's such a mouthful. How does design, architecture and engineering affect behavioural outcomes? So it's design, architecture, engineering influencing behavioural outcomes. I was interested in products, buildings and districts. So we all know that product designers do understand behaviours quite well. I mean, advertisers and marketeers know that. Apple know how to get you to buy an iPad and so on. So Jonathan Ive, their principal designer, knows that. But actually, when we look at buildings, the architects actually put their hands up and say, no, actually, we've been doing this for different reasons. I mean, we do design for particular outcomes, but we also design for aesthetics and so on. There may be sometimes some tension between them. And I was surprised that RIBA, the Institution of British Architects, actually bought into that proposal. For districts, it's mixed. There are some tools that help us there, but we're not terribly well advanced in that area. So this is the picture I thought you might be amused by, if you just read the text. So true, isn't it? I thought it's a really cunning idea. So this is our DIBO project. So we have 4 partners, 1 year, 3 workshops, 120 delegates. We had some really good people. We're going to publish something with the Royal Academy of Engineering in July this year, and we hope that will lead to some joined-up funding from the Research Council. So ESRC say they like it already, and we've got some good partners. And these are some of the things we're looking at. So it's a huge sea to boil. So you have to choose the things that you really want to work at. We're working on health and well-being, energy waste and water, resource efficiencies, and for people who design offices, how do you get a little bit more performance and productivity out of people working in offices by being more comfortable and happy across a range of scales. And the research outcomes, the key conclusions were these, and ESRC are backing these. These aren't necessarily what will be in the call, but there are some suggestions. So carbon use, empathic design, design with people at the centre, human-centred design. How do you influence people's perceptions of how well they are and how secure they feel? How do you deal with consequences in poorly working systems? The role of big data we've covered, and they're looking at the complex relationship between behaviour and the environment. What we want to avoid is Fritz Lang's metropolis. What we want to do is to join up our understanding across social and physical sciences using the technologies I've mentioned there. There's a huge amount of opportunity. We're not short of technologies or real excellence in science and engineering to do this, but we do need to join up with behavioural science. And then just very briefly and towards the end, these are some interactions that pertain to my present work in insurance. A Venn diagram, and I shall briefly go through it. So science and policy, science advice to government. So I've been involved in that, see how that works. Capital and policy, new funding models, we need some of those. And science and capital, so de-risking investment. And putting it all together, we think that the insurance world, it's not about selling insurance policies, but about understanding risk better and covering those three intersections, we can actually promote better outcomes. We can also look to alternatives to legislation, and without going into great detail in this diagram, by getting people to buy into particular social norms of personal social responsibility rather than being told what to do, we can actually achieve some outcomes rather than going through the bottom route, which is policy regulation. We can go through media socialisation, insurability. For example, the issue of putting a camera in a car and having your policy linked to how you're driving rather than actually being told to drive more safely. You have a direct interaction. It's your choice. That's the key thing as to how much you're going to pay, how carefully you're going to drive. And in conclusion, government is continuing to do some good work. So the Foresight group in the Government Office for Science, which you may well be aware of, is behind the scenes working to produce some really excellent policy options to do with cities and where we need to look at research as well, holistic understanding of challenges and seeking some inputs as well from the community to shape what they're doing. So I recommend the website, look on Go Science, look at Foresight, see what they're doing, and those publications that have come out from the previous work are available for use, and they're very, very interesting and in-depth. So my final slide is really what do I consider cities in the 22nd century to be like, and this has been refined over a few years, I suppose, from when I worked on so-called sustainable cities with Arup. We worked on the Dongtan Eco-City, which had a sort of mixed press, but actually did lead some thinking and interesting work, including enduring research links with China. So I think we're looking at a design, data, physically integrated, resilient, organic system for the city. It's probably going to be high density, low rise, mixed use and walkable. If you think of Florence, lovely city, actually, even back in the days of the Medici family, the Uffizi, they could walk across the bridge and just go to work in the city. District level thermal and electrical energy from waste and renewables, we're actually seeing that happening now. Decarbonised electricity I've touched on, so maybe that means initially shale gas, not truly decarbonised, but better than coal, and then ultimately maybe using nuclear, but high voltage DC links to Europe. Renewables are great, but actually we need to store energy if we use these supplies which are intermittent, and that's a whole other story I'm not going to go into now. Water recycling and management. I think interestingly, what's going to happen as we onshore stuff out of the low-cost countries, out of the BRIC countries, already General Electric is moving manufacturing out of China back into the States because energy is cheaper again there. So are we going to do things differently? Are we going to make things local to the point of consumption? That makes sense for food, for example. Service provision rather than capital goods. We may alter our dietary habits. If you think about meat and, particularly eating beef and so on, and the climate impacts of that. Ultimately, we're going to go past the demographic bulge, and we need to think about how that's going to be and how we're going to get behaviour change to stay there And then we already see new work styles enabled by high bandwidth ICT. In fact, I was sitting next to an IBM employee on the plane, and he was basically saying they're closing most of their offices and people are working from home. So it's actually happened now already. It's the fastest moving piece, I think, of our smart city jigsaw puzzle. And I just thank you very much for your attention.
Would you like to sit here to answer some questions?
Drink some water.
Well, thank you very much indeed, Jeremy. It was a fascinating talk, and you raised some really important questions. I'm delighted to know that my city of Glasgow is a smart city. I didn't know that before. But so if you'd like to ask a question, could you raise your hand? And we have some colleagues here who will give you the wait to get to the microphone, and if you could identify yourselves, please. Thanks very much.
I've stunned you. Sorry.
There's at the front here, that lady. Thank you.
Thanks. I didn't know that you'd moved to insurance, so that's provoked my question. Given that climate change is going to cause higher insurance premiums, and they could be really high, given that people need to be given a sense of urgency, couldn't your industry get together and form a sort of cartel, alarm everyone with the idea that they're going to be astronomical premiums, and get a bit of urgency going?
Yeah, thank you for that. Yes, and I think that's happening, but it's happening at a national level, so that the practice in which I work, our CEO, is already, say, addressing the UN and working with Ban Ki-moon at that sort of level to raise the profile internationally. So I think it has to be at a government level first of all, but it has to be at a global level to make any difference at all. And ultimately, we're also looking at the other end of the spectrum, which is really about flood risk for individuals. I can't talk too much about that for reasons that I mustn't be aligned to it because of this flood reinsurance thing, but government is taking that very seriously and work is being done. And for example, I sat on the Science Advice to Government and Emergencies panel that advised COBRA in February in number 10, just sorting out Somerset and the Thames Valley. And so understanding some of the great inconvenience, disruption that's caused actually to people and what they can do to help, as well as the insurance industry and government.
This gentleman here.
Hi, I'm Hilary Sillito. Until recently, I was the Systems Engineering Director for Thales in the UK. I've recently retired and extremely interested in all that. Thank you for an outstanding talk. You've talked quite a lot about ICT assuming that cybersecurity issues will be solved. And then at one point you said that it will be an ongoing, continuous evolution.
Yeah.
What if that goes the wrong way? What if it can't be solved? What's the risk of that and what's the impact?
Well, it concerns me personally, I have to say, to be quite open about it, but colleagues that I talk with, both in government and the private sector, who are experts in that field, as I'm sure you are, feel with the right investment. I mean, it depends the sort of attack you get. If you've got a government versus government type attack, then I won't name particular countries, but then it's a much harder thing. But against commercial hacking or the sort of criminal element, fraudulent hacking, then I think there are interventions that will be developed. And I think actually I'm aware that Mike Lynch, the founder of Autonomy, is currently working on a smart agent technology that is learning the nature of attacks and actually countering them automatically. So I think actually human intervention won't be quick enough. So we need machines against machines to deal with this. But that's just a personal view.
Yeah, quite.
This gentleman in the black shirt thing.
Hi, my name's Stephen Allen. I'm from National Museums, though asking in the personal capacity. You touched on this quite fleetingly, which is really the gap between the development and in informing public policy and then the implementation of it. You did touch upon political leadership to an extent. And it was an absolutely fascinating talk, which joined up a huge amount of things, which took together huge bits of information and policy. But we just sat through, and indeed are sitting through, an awful lot of political discourse, which focused on anything but those elements. Over the last few weeks, we've heard nothing but rhetoric about immigration, and very, very little about long-term planning. So where is that political leadership going to come from? You did touch upon it as being in where the cities and more locally driven. Is that the way forward?
Thank you. A really deep and important question, which I could only partially scratch at the surface of. Yeah, I think it's really about the citizen being made better aware of the issues, and we need to find ways of getting quite deep facts across in a straightforward soundbite sort of way. So you're not giving anyone a deep course on socio-political issues, but actually giving them better awareness than perhaps they'd get from the red top newspapers, a more balanced view. And if you think, an end point might be, wouldn't it be great if we could drive things through sort of referenda via the internet or whatever? But people would really have to be educated in those issues, and they might even need to be qualified and demonstrate they knew enough to actually. It's very divisive, but it's a view, isn't it? The other approach is to try and gamify some of the decisions, I think, that people might want to take. And an example was from DEC, so Department of Energy and Climate Change. The 2050 calculator, I don't know if you've looked at that, gives people the option to play with the energy sources and the energy demand and use different interventions. So you might say we go completely wind-powered and we have all-electric cars. And you can start to see how practical that is because the toolkit just tells you how near you get to the objective. If we could do that in other areas, we might start to persuade people to just, like a SimCity type of thing, people would get engaged in that. And perhaps we could bring the awareness up sufficiently so they understood, for example, with immigration, that in fact the fiscal benefits of having more people working in the UK outweigh any apparent displacement of jobs, which may be partially fictitious.
Yeah, I like the slide you had that had smart governments right at the centre of it. There's a gentleman at the very back seat.
Thanks. Michael Burns from the University of Glasgow. Quick question on the big data phenomenon. In my own city, we've got about 6 or 7 big data centres emerging, run by health, run by universities, concerned with education, concerned with housing, none of which is coordinated especially well. Do you have any views on the North American model of a chief data officer or a data commission at the city level to represent the interests of the whole city and not just a fractured series of interests from a range of competing organisations quite often?
Yeah, I've got a view on the generic issue, I think. I can't cite specific cases in North America, but I'm aware that having an overarching responsibility for these things through a chief information officer or whatever is a very positive thing to do. I think in companies as well that's been seen. And I think there's the story, again, the missing piece is about the value aggregation, the extra benefit that everyone can share by working together. That seems to be so difficult to get across to anyone who writes a business model, that actually let's look outside at the externalities and join up, and then let's share the benefit that we get through doing that. So I think that's my answer. I firmly believe that the overarching thing is a great idea. And I think the Olympics and the ODA were a bit of a model for that. You know, there was actually a requirement to work together, and it created a very good outcome.
The gentleman in the third back row there, glasses.
Hi, it's a general question about London. Every time I go there, I mean, I'm in awe almost of the amount of investment and change that's happening in the city. And I just want you to comment, what chance have other cities within Britain? Because it seems to be becoming more and more dominant. I mean, the area behind King's Cross, for example, yes. I remember what it used to be like. I mean, I don't know if there's anything like that in any other city in Britain.
It's a very good question, isn't it? I mean, I think there is a certain critical mass type phenomenon, isn't there, of the right people, the right money in the right place. I don't think it necessarily is just going to be London-centric. I think we need to think about what are the critical elements for that in other places. And there was a time when Peterborough, used to boast of its economic community, in Cambridge as well, and so on. And there are places like Daresbury, where there are science centres being built up. And I think it's quite interesting in the UK, you're aware of the local enterprise partnerships, the LEPs, have been a mixed success, really, depending on the amount of money they can mobilise. But there are some very good examples, like Manchester, where I think we're beginning to see economic aggregation and capability. But it needs to be encouraged, I think, by central government. And I don't think there's probably enough money going into the regions to help with that at the moment. They can't necessarily do it all themselves.
The lady at the third row here.
Hi. The emissions that are directly attributable to the built environment have been understood for well on 20 years. I mean, this is not new information for anyone in the trade. And yet we really haven't done much of anything, even though we know what to do. And the Green Bank, I think could be said has failed. I think within the built environment world, we know it doesn't work. We knew it wasn't going to work.
Yes.
And it's not a surprise that it hasn't worked.
Yes.
So what do? How do we either completely overhaul it because it is not an effective vehicle for what needs to change, or what do we need in its stead?
Okay, I mean, very salient, and the eyes of a realist there, I think. And I, I felt the same way when I was in DCLG. I'm working with DEC and so on as a partner. Very difficult to see how we were going to do it, and I think it's just simple interventions like insulating buildings won't do it. I mean, it can go a little bit of a way towards helping, but if you're going to spend, say, 400, I think I had billion pounds by 2050, I think I'd rather build a few nuclear power stations, decarbonise energy. So I think the French model is a good one, particularly if we're going to decarbonise transport. It's kind of and combine it with renewables. I know I'm in Scotland, and that isn't going to be terribly popular. But I think, the emerging technologies around nuclear are very much advanced over where they were. And I don't think we've got many options, really, if we're going to keep on our growth profile. I mean, that's another question about growth, isn't there? Can you grow infinitely? Clearly not, but none of us is going to say where the limit is. So there's an interesting question, I think. Obviously, the demographic bulge is going to mean the question is around how do you create economic well-being rather than growth. I think that's the question in maybe a diminishing population. I guess Japan will get there before we do with their ageing demography. But I do take your point, absolutely, and it's a very hard question to have to face. Renewables will go so far. If you read David Mackay's book, you'll know what the arguments are. I think he put them very, very well. And if we do more renewables, we need to partner with, say, Norway, who've got pumped storage with high voltage DC links. We need to reduce the consumption of energy as well, so that we can make the whole thing manageable. But we also need to think about growth.
If you could pass your microphone to the gentleman next to you. Oh, you would have it, right. And if you could identify yourself too, please, thanks.
Dermot Campbell, British Geological Survey. If you look at global populations as a whole, the suggestion is that the population of Europe is fairly stable. Maybe the Americas are also stabilizing. Asia's got another billion people, maybe are going to appear in the next 100 years, but the real growth of the world population is likely to be in Africa, with maybe a growth from 1 billion to 4 billion people if they stay healthy by the end of the century. How important is it that we should be assisting urban development in Africa, do you think? And how can we do it?
Yeah. I think it's vital. I think education, it's always cited, isn't it, as being, particularly of women and so on, and the fact that just having children isn't the sole way of ensuring your old age and economic well-being through having them work on your land or whatever. The optimum size of family will become sort of self-evident, if you like, rather than driven by necessity, through mortality or through the need to have people working on your land and so on. So I think education's key. I think very recently, you're probably aware of the Newton Fund, which has emerged. Others may not know about this. So I think it's 320 million, which has been mobilised to encourage universities to work with overseas organisations. It's come out of the Department for International Development. And it will, I think, when it's shaped, it's still in the early stages, help to do the sort of work that, in a small way, 300 million, it doesn't go a huge way around the world. But education, giving examples, say, of the engineering and agricultural skills that might apply in Africa. I mean, I think stabilising the political situation is pretty important as well, isn't it? So that people actually can concentrate rather than just fleeing wars. But that's broadly my answer. I firmly support what you're saying.
This gentleman here on the... Thank you.
Yeah, Cliff Haig, Built Environment Forum Scotland. Just picking up the last bit, it's not just demographic growth in Africa, but the size and speed of the growth of the middle class and their consumption patterns. It's a real key part of that equation. But my question really is, going back, I'm trying to find my notes, 22 million homes to retrofit by 2050, £5,000 to £20,000 a home. Of course, 20% of that money goes back to government in the way of value-added tax. Is there any chance in your discussions with people from the Treasury of getting an approach to value-added tax on repair and maintenance that might actually encourage behaviour that would be seen by everybody here as desirable?
Very good point. I mean, note that I've been out of government now for nearly, well, not quite 2 years, 18 months, so I can at least make the point as an independent person, and I think it's a very good point. I think there are interventions that could be made there. That, you know, and many others as well, including sort of subsidised skills development and so on, actually marshalling the industry to be a more joined-up entity as well. So integrated project insurance type activities. But I think it's a very good idea.
Yep, Pat Corbett, Heriot Watt, Energy Academy. The message about we can all build a few nuclear power stations and then everything is solved is, you know, that's not a very sustainable city if you have to have a nuclear power station somewhere else. And, you know, if you take the argument there's 4 billion people in Africa, how many nuclear power stations would you build for Africa? You know, so leadership is important, but leadership just saying you build a few nuclear power stations, I don't think that's the answer. No,
I suppose comments I take the point, but those are actually making that decision is within the national capability. Let's put it that way. The more sustainable approach might be, okay, let's put lots and lots of photovoltaics in North Africa, but you've actually got to sort out all the political issues for that and then ship that by high voltage DC into Europe. And again, Mackay makes it quite clear how much you'd need, and it's doable. I mean, it may also be doable to actually create artificial hydrocarbons using solar energy, you know, in countries which traditionally mined them or drilled for them. And I think that's something else that we should look at. So if you allow for those international and political issues to be resolvable, then there are much better ways of doing it, I agree. But I rather glibly talked about nuclear because I think decarbonised electricity is the way to deal, for example, with the heat leaks in properties. I mean, you won't deal with the whole problem by just insulating properties better. And I did some work on that, which I don't want to talk too much in detail on, but actually the sensitivity on the outcome of doing that is rather small compared with the amount of money you have to spend.
Any further questions? If not, can I thank you once again? That was absolutely terrific. And can I call on Dr. Gordon Masterton to give a vote of thanks?
Well, thank you, Chairman, and thank you, Jeremy. It must have been quite intimidating for Jeremy to look at the distinguished list of past Edinburgh lecturers, which almost reads like a who's who of international statesmanship and thought leadership. Stephen Hawking, Mikhail Gorbachev, His Holiness the Dalai Lama, Alex Salmond. That wasn't meant to be a joke. It's interesting that it was. Anyway, but we needn't have worried because Jeremy can hold his head up high and stand alongside the equal billing with any of the above following this evening's lecture. Jeremy's an engineer, and he made me proud also to be an engineer. That's my profession, because he demonstrated very, very clearly that engineering is not about tinkering with machinery, wearing oily overalls and having a permanent exasperated expression on your face. It's a bit more sophisticated than that. And to engineer really is to make things work, to solve problems. And Jeremy has demonstrated tonight that to do that for complex systems, indeed systems of systems like cities, engineers definitely can't do that alone. And the solution lies in much more multidisciplinary, interdisciplinary thinking being applied before we rush on and just build more stuff that engineers are very good at doing. So it's it's a much more complex issue that needs to be resolved. And it's encouraging that the quality of thinking that's going into these issues has acknowledged the multidisciplinary need to engage across the entire community before we make important decisions, because decisions on city building tend to hang around for a very, very long time. It's probably about 25 or 30 years, you're stuck with most of the infrastructure that we build today. When we get it right, it's a harmonious collaboration, either by accident or design. We've got some wonderful cities that are a joy to live in and a joy to work in. But of course, it'd be better if we could do this by design rather than by accident. And the Q&A also demonstrated that Jeremy's made us think, and think very deeply about the issues. And the topic was future cities, not smart cities, future cities. And predicting the future is very challenging, very difficult, obviously. And it's not just about extrapolating from where we are now. Jeremy again demonstrated that to us. If, for instance, there was a foresight group for London in 1851 at the time of the Great Exhibition, it would be looking at a city that was growing rapidly in population. It would have been looking at a transport system that would start to be stressed by that growing population, and it would conclude, if extrapolation was the only tool in its toolbox, that we need to invest in stud farms rapidly. We need to reskill the next generation of farriers, and we need an army of people just to clear the manure off the streets, because horse transport was the means of transport that was used by everybody. Now, of course, that didn't happen because the advent of the railway systems and then later the internal combustion engine. These were step changes that weren't picked up and wouldn't have been picked up by extrapolation. So thinking about the future is really, really complicated. And it needs probing behind the systems of systems, and how they're likely to interact. But what's important is that we do have that quality of conversation, the quality of thinking, so that we're more likely to get it right than to get it wrong. Yes, it's about engineering the future, but it's about engineering the right future for us as well. And Jeremy tonight has given us some of the tools in the toolbox to help us to be able to do that. So, ladies and gentlemen, could you please show your appreciation for Jeremy in the usual way? Thank you very much.